We are up and running. See, I just got a message. Did you start the live stream? Let me answer this message. Yes. Just now. All right. So you probably maybe you noticed if you looked at the title closely, but I listed this today as 3.3 review. I got some questions, and then I looked at the assignment, and I could see the format was a little different than what I had time to tell you last time. So I don't know. It just seemed like maybe we need to spend a little more time on lesson 3.3. So I've not got anybody live today because we had a little abortion here that I had to recover from. But the three categories of questions I got from an email were: do some problems from 37 to 43, that section, then the 49 to 55 section, and the 57 to 64 section. So what I've got up here is the first one from that 37 to 43 section. This is the section where it says in the book, express the function in the form f of x equals x minus k times q of x plus a remainder. So in other words, express it as a multiplication. Yeah, and then I know that last part I never talked about either. So anyway, here's problem 37. Now, the way I've got this showing right now, this is taking off my keyboard here. This is doing the problem with synthetic division. It can also be done with long division. So you guys let me know if you want me to do it that way. I will. So on number 37, you notice they gave us this polynomial, x cubed minus x squared minus 14x plus 11. Well, that's what I currently have written. I've got the coefficients right here in this synthetic division grid. 1x cubed minus 1x squared minus 14x plus 11. So that's where I got those numbers from. And then on the right, it said, all right, x minus k. Well, in this case, it's x minus 4. So I'm really dividing by x minus 4. And like I taught you yesterday, x minus 4, what value of x will make that 0? 4. So that's why I have a 4 in that position. Okay, so anyway, I carried out the synthetic division. I'll repeat how to do that. You bring down the first digit, 1, then you multiply 4 times 1, and that's 4, and you place that in the second column. Then you add up the second column. -1 plus 4 is 3. Now you take the 3 and multiply it by the divisor up there, 4. 4 times 3 is 12. Put that in the next column, add. This time we get -2. Now take 4 times -2, which is -8, add. And we found the remainder of 3. Okay, so in effect, here's what we found out. That x minus 4 divides into that original polynomial, and this is the answer you get. 1x squared plus 3x minus 2. Those are just those numbers from the synthetic, and then the remainder is 3. If you were writing this answer the more grown-up way, you would write plus 3 over the divisor of x minus 4. But the remainder is 3. So now, the one thing I haven't demonstrated is you were supposed to demonstrate that f of k equals r. So in other words, can I show that f of 4 is the remainder of 3? Well, just go back to the original polynomial. Okay, the original polynomial is what? X cubed. Okay, what's f of 4? So you got basically 4 cubed minus 4 squared minus 14 times 4 plus 11. So let's just do the arithmetic. That's 64 minus 16 minus 56 plus 11. So a little bit of arithmetic here. 64 minus 16, that's 48. And if you take 48 minus 56, that's a -8. And -8 plus 11 is 3. So we showed that when you take f of 4, you really do get the remainder of 3. Actually, that's a foreshadowing of what's called the remainder theorem. If you want to know the remainder when dividing by x minus 4, all you have to do is plug in a 4 into the original function. If it comes out, whatever it comes out to, that's your remainder. So if the remainder had come out to 0, we would have known ahead of time that it would divide in evenly. This time, we didn't know that, of course. I'm just telling you about it. But you can see that f of whatever that number is over here on the top left, in this case 4, is 3. So that's a really cool foreshadowing. Anyway, that's what they wanted you to do on number 37. Now, we could have done it with long division too. And if you want, I'm going to do another one of these. And if you want, I can do that with long division. I'll pause a little bit and see if anybody wants to. Maybe I did this one with long division. Oh, I did. Yeah. 43 is kind of a stinker, so let's take 43. Okay, this time we've got this polynomial that I've got in here. And it says you're supposed to divide that by x minus, and then what did they do? They gave us an imaginary number. 1 minus, not an imaginary number, but a 1 with a root in it. 1 minus the square root of 3. So what I'm really trying to do here is divide by x minus, parentheses, 1 minus the square root of 3. Well, if that's the case, do you see how I got this? I just applied them, here we got the old, basically we have a distributive property, and if you carry the negative through, it'll make that 1 a negative, and it'll make the square root of 3 a positive. Does everybody see that, first of all? Okay, so you can actually do this long division. So let's get started. So you first take a look at the x, and you take a look at this first term right here. And you say, how many times is x? What times x equals -4x cubed? Well, that's -4x squared. Okay, -4x squared times x, that's easy, -4x cubed. What's -4x squared times this thing I just put in parentheses? Well, let's just write it. I mean, if you take -4 times -1, you get 4. And if you take -4 times square root of 3, you get -4 times the square root of 3. And I just left the x squared outside of the parentheses. That'll make it a little bit easier. Okay? So now I've got this big fat x squared coefficient. Can I actually subtract? Sure. I have to take 6 and subtract 4 and subtract a -4 times the square root of 3. Well, what's 6 subtract 4? That's 2. What's 6 subtract 4 times the square root of 3? Well, I mean, let's see. What did I do with the 6? Hang on a second. Oh, I already subtracted the 4 from it. That's why I got down to 2. So I'm subtracting -4 times the square root of 3. And when you subtract a negative, that's the same as adding. Okay. So, all right, x squared. So I subtracted the coefficients. I've got that term. Then I brought down the next term. All right, now what times x equals this mess? Well, it's basically that big old mess coefficient, 2 plus 4 times the square root of 3. So you notice, there it is. That times x, because I only have a single x. Anyway, then these ugly things cancel. Well, when I multiply, I also have to take this 2 plus 4 times the square root of 3x times these parentheses here again. So it gets a little messy. But anyway, I don't know if I need to go through ever better detail, but it does come out even because we got a zero remainder, which is really cool. So it actually divided in. So now, with the directions of the problem, what's the x minus k? Well, I just copied this thing we have out in front here, down here. What's our answer? I copied that from this way up on the top here, that big old thing. And then plus, what's our remainder? Our remainder is 0. Anyway, I thought we might need practice. That was probably the hardest long division. Maybe nobody did it that way. And of course, you have the same kind of difficulty if you do this in the shorter technique, which is called what? Synthetic? Well, 43 was kind of over the top, but anyway, there's that one. So that's one question I was asked, the 37 to 43. We did a couple from there. I'm going to pause. Questions? Oh, Kirsten is asking about number 13. Thank you, Kirsten. I'll maybe do that one next. Okay? Yeah, I know it takes me a long time to react. I got a lot of things to look at here. So anybody, but while I'm at it, I did 2 problems from the 37 to 43 section. And as long as I have one of those up, does anybody have a follow-up question? All right, then I'm going to go to number 13 next, which I just got that. I got that request from one of the online people. Number 13, use long division. So here they definitely want us to do the long way. Okay, so we've got 2x squared uh, 2x squared plus 1 divided into 6x cubed plus 10x squared plus x plus 8. So I've got it set up. I don't have it set up to do it over, but let's just talk it through. So now what's a little different is I think this is the first time, and I can see what maybe you're asking, Kirsten. This is the first time I had what? Anything other than a first degree term on the outside here. But notice I'm going to handle it the same. Take a look at the first part, the first term, 2x squared, and divide it into the first term of what you're dividing into. What times 2x squared would be equal to 6x cubed? Well, we need a 3 and we need an x. Oh yeah, 3x. Multiply 3x times 2x squared is 6x cubed. Now here's where it gets a little weird. What's 3x times 1? 3x. I can't put that here. Why not? Because it doesn't agree with the it's not a like term to 10x squared. So see if I can undo that. Yeah. So do you see where I wrote it? I wrote it under the x term. So that's probably what goofed a few of you up. And again, it was something I didn't have enough time to. We just don't have enough time to try all the kinds of problems. But anyway, so I've got it under a like term. Now, when you subtract, I still have to subtract this column too. The 6x cubes, yeah, they're gone. 10x squared, yep, well, I still got a 10x squared. And what's x minus 3x? A negative 2x. Okay, bring down the next term, plus 8. All right, now you've got to, in your mind, you've got to say to yourself, what times 2x squared equals 10x squared? And that would be plus 5. Plus 5 times 2x squared is 10x squared. 5 times 1 is 5. Again, I have to stick that in. I can't stick that underneath an x, so I had to skip a column again. And now when you subtract, goodbye x squareds, we still have a negative 2x, and we have a 3. Well, we're out of terms. There's nothing else to drop. So what we just found out is this is our remainder. So what's the answer? What's on top there? 3x plus 5. And then take your remainder, negative 2x plus 3, and put it over the divisor. So result, I would write like this. Is there any follow-up to number 13? So, got the dog needing attention here. Wonderful. All right, I'm going to go to the next section requested by email the other day, and that's the 49 to 55 section. All right, so I'm going to go to number 53, which is in that group. What do we have for directions here? Use synthetic division to show that x is a 0 of the third degree polynomial equation. That means it's a 0. That means it should divide unevenly. So if on number 53, what is x? Square root of 3. So you notice that's out here. What are the coefficients of the polynomial we're dividing into? 1x cubed plus 2x squared minus 3x minus 6. Okay, so the only thing that's a little different here is we've got a root. Well, you know what to do with it. So first you bring down the 1. Got that in place. Now multiply the square root of 3 times 1. Put that in the next column. Now add. Yeah, we actually have a little bit of a, we got a two-term answer here. 2 plus the square root of 3. Now I have to take the square root of 3 and multiply by that binomial. So the square root of 3 times 2, that's this part, 2 times the square root of 3. And then plus, what's the square root of 3 times 3? 3. All right. Add. Well, a nice thing happens. Negative 3 plus 3 drops out, and all I have left is 2 times the square root of 3. And then another nice thing happens. Next, your last multiplication, what's the square root of 3 times 2 times the square root of 3? Well, square root of 3 times square root of 3 is 3, and 3 times 2 is 6. And look at that. Negative 6 plus 6 gives us the 0 remainder we were expecting from, it said show that this is a 0. So they were telling us ahead of time that the remainder should come out to 0. And it did. Is there anything else we're supposed to do there? Oh, list all real zeros of the function. Okay, so we know one is, we just found this one works, right? Okay. Now, I don't know how much time we have, but I was able to factor this into these two factors. And so this is, what x will make that a 0? Negative 2. What x? So basically, there's the other two. So this one is the one we found by dividing, and then by factoring, we found the other two. So there really are 3. So the book said the book told you to do 2 things. Show that the square root of 3 works. We did that right here by that asterisk. And then it said, show all the real zeros. That would be done basically on that line. So there's number 53. So now I've done one of that section. Maybe we can come back and do another. Let me pause again. Any questions? Kirsten left. She joined. Oh, she's having troubles again with her computer.
I've got a quick question.
Yes, go ahead.
When you run the factors, why is it like the middle term is like 2 plus the square root of 3?
Yeah.
So why do you factor it?
Yeah.
Like, why is it doubled?
What did you say? Why is it doubled?
Or why is it like when you multiply?
Why is it 2 plus the square root of 3 times x? Yeah, I'll tell you what. I think to answer your question, look down in this factored row here. Let me show it to you backwards. If we multiply, okay, we know that x times x is x squared, so that's no problem. Then you're going to multiply x times the square root of 3. So we've got square root of 3x. I'm going to write that over here on the left. And then in the now you take 2 times x, all right, 2x. And then lastly, 2 times the square root of 3. Well, we know that's that. Well, look at these two terms. This, I could have written I could have put this right here.
Okay.
But if you look, you could take an x out of that, and do you see that's the same? Yeah. Yeah, so you probably would have been fine if I'd have written it like that one on the left there, but it's really the same thing.
Okay.
By the way, do you see with this answer right here, do you see how that matches up nicely with what we did up here in the synthetic?
Yeah.
That's why I did it.
Okay.
But this thing over here on the left would have been just fine. It still would have. Yeah. The thing is, yeah, I don't know what else to say except, see, this way right here is what we had for our answer up on top. That's the reason I wrote it that way. See that right up here? There's the coefficients. Right? Yeah. And you're right, it's a little harder to see. It was a hard one to factor. I'll agree with that. You're not used to seeing it look like that. Thank you for asking that question.
Sure.
Anybody else before I go to that third section? Let's move to a problem or two from the 57 to 64 section. Okay? I'll start with number 57. Now, 57, what do we have for directions? It says use synthetic division. Looks like I didn't use synthetic division. But use synthetic division to show that x is a 0 of the third degree polynomial. Oh, no, I'm in the wrong place. Sorry. Verify the given factors of the function. So, how can I verify that? How can I show that x plus 2 is a 0? Well, if x plus 2 is a 0, then this would be a solution, correct? Right? If x plus 2 equals 0, then wouldn't x equals negative 2? All right. Well, check it. Go back to the original function right up here on the top and plug in negative 2 and watch what happens. Okay, in the first term, negative 2 cubed is negative 8. Negative 8 times 2 is negative 16. In the second term, what's negative 2 squared? Positive 4. In the third term, what's negative 2 times negative 5? Plus 10. Okay, add those up, and what do they come out to? 0. So that one's verified. it is a zero of the function. The next one we predicted was right here. Should be x equals 1. Let me erase this section up here. Let's go back. Let's prove that that works. Okay, what's f of 1? What's 1 cubed? 1 times 2 is 2. 1 squared is 1. Negative 5 times 1 is negative 5. Okay, what happens when you add those up? 3 minus 5 is negative 2. Negative 2 plus 2 is 0. Yep, that one works. And then, let's do it one more time. This time, our third factor over here from 2x plus 1, set that equal to 0 and solve, and you're going to get x equals 1/2. A little bit harder to calculate, but let's do it. 1/2 cubed is 1/8. And 2 times 1/8 is 2/8, which reduced is 1/4. Okay? 1/2 squared is 1/4. 1/2 times negative 5 is negative 5. That's supposed to be, that's a 5. Negative 5 halves. And lastly, we have plus 2. Okay. What's 1/4? Here, let's just add those up. What's 1/4 plus 1/4? That's 1/2, right? And what's 1/2 minus 5 halves is negative 4 halves. And negative 4 halves is negative 2. And negative 2 plus 2? Okay, we've done it. We've verified that all three of these really are zeros of the function. Okay, that was what? The first part of that one? That's part A. What are the remaining factors? Okay, well, all right. So let me think this through here. We found 3 factors already. We should be done. How can I check? Well, let's take these 3 and multiply them. Okay, let's see. I'm going to have to make some space here. So let me scroll down. So, whoop, I got to go up just a little bit. All right, what's x plus 2 times x plus 1? Here, let's just do this one first. X plus 2 times x minus 1. X times x is x squared. X times negative 1 is negative x. 2 times x is 2x. 2 times negative 1 is negative 2. That's x squared plus x minus 2. All right, and then we have to multiply that by 2x minus 1. See where I'm getting those from the very top of the page up there. And that should equal what? This thing we started off with right here. Okay, x squared times 2x is 2x cubed. X squared times negative 1 is negative x squared. X times 2x is 2x squared. X times negative 1 is negative x. Lastly, negative 2 times 2x is negative 4x. Negative 2 times negative 1 is plus 2. All we got to do is gather. 2x cubed. We have a minus 1x squared and a plus 2x squared, which is a plus 1x squared. Then we have a minus x and a minus 4x. That's a minus 5x plus 2. And if you look, that perfectly matches. We got them all. So when they said find the remaining factors, in this one, there are no remaining factors. We already have all 3 of them because when you multiply them out, they equal what we began with. So in this case, there were no remaining factors. Question or comment on that one?
If there were remaining factors, there would be a remainder when you multiplied it out then, right?
Well,
Like it wouldn't match?
it wouldn't match, correct. And how could we find the remaining factor? By dividing, by dividing the answer down here into, the polynomial we had originally, and then you'd get the remaining what was left. Maybe we'll do another one, and maybe the next one will have remaining factors. I can't remember. So let's do 61 and see. Maybe we'll have an example of one like that. Okay.
Okay.
So let's take 61 and see what happens there. Okay, 61. We have this x 6x cubed plus 41x squared minus 9x minus 14, and they gave us two factors. They gave us 2x plus 1 and 3x minus 2. Okay, if you look way to the bottom here, I took just those two that I've underlined, and I multiplied them, and I came up with this. So 2x times 3x, 6x squared, 2x times negative 2 is minus 4x, and then later you get a plus 3x. That's why you get a minus 1x. And then 1 times 3x is, we already did that one, yeah. So anyway, here's what happens when you take the two factors they gave us and multiply them. Okay, so you notice what I did on the top is I said, all right, let's see if there's another factor by dividing by that. So here's kind of what you were just asking me about. I don't remember who that was. I don't actually know. I think that might have been...
It was me. I'm Geneva.
Yeah, I have no pictures here, so... Who are you?
Geneva.
That's right, Geneva. Sorry. I had you in my mind. I couldn't think. Okay, so here's the factors they gave us multiplied out. Let's divide it into the polynomial they gave us. Let's see what... Do we get something this time? Yeah, obviously we don't have the whole thing here, do we? All right, so here we go. This is maybe this is the first time we've divided by a trinomial, but you can still do it. Take the first term and divide it into the first term. What times 6x squared is 6x cubed? X. X times 6x squared is 6x cubed. X times negative x is negative x squared. We're lined up okay. And x times negative 2 is negative 2x. So we didn't have to skip a column this time, did we? Subtract 6x cubed, gone. 41x squared minus 1 is minus a negative 1. You wind up adding and you get 42x squared. Negative 9x minus a negative 2x, you actually wind up adding 2x and you get negative 7x. Bring down the last term, negative 14. Okay, now, what times 6x squared equals 42x squared? Oh, that's just plus 7. 7 times 6x squared is 42x squared. 7 times negative x is negative 7x. And 7 times negative 2 is negative 14. And voila, we have no remainder. So what's the remaining 0? This was the missing factor. We just found it. So what are the 3 zeros of this function? Well, 2x minus 1 set equal to 0. You know, I'm not going to do it, but you subtract 1 and divide by 2, you would get this answer. 3x minus 2, you get this answer. And then the one we found. So here's what you were asking about, I believe, Geneva. Here we did not have everything covered, and we had to find the remaining factor by taking the product of the two they gave us and dividing it and see, you know, and check out what's left. Okay, we've at least covered the questions that I've received. Now let's go for some more live from anybody, or text message or email or whatever. What else from 3.3 would you like to talk about? Okay, anybody Questions remaining yet from the 3-3 assignment? Okay, I'm not hearing any. So there is no new assignment for next time. The goal tomorrow, you know, I'm not going to give you an assignment tomorrow either because, you know, we need to dig into trigonometry the following day. So, but I am going to do pretty much a massive demonstration of what is possible in lesson 3-4. So I just kind of want you to sit back, maybe take a few notes, but you'll have, I want you to just observe when you put all these tools together, what you can do with even higher polynomials and how you can actually find out what this, how this strange looking function operates. Well, okay, thanks. I appreciate you guys having we had a little bit of a rough beginning, but it went better this time. Thanks for hanging in there. I seem to be getting really good at rebooting. I'm being sarcastic because that's not a fun thing. But anyway, it went relatively quickly today. We didn't waste 15 minutes. I think it only took about 5. Does anybody have any questions you want to add to this? So another comment here. As soon as we get off here, I'm going to get this video wrapped up and post it. I'm going to post this under lesson 3.3 because that's really what we even, you know, it wasn't the teaching of the lesson, but it was more on lesson 3.3. So you'll see a link here and it'll be under the 3.3 with today's date. Thanks everybody. Kirsten, I'm sorry we lost you. We had you for quite a while and made some comments and then we seem to have lost you. So hope to see you on the video. Thanks everybody. I'm going to wrap things up now. Have a good one.
Thank you, you too.